Try this mental math problem. Take the number 1 and divide it by 2. Now divide by 2 again. Divide by 2 again. One more time. Finally, divide it by 3. What's the answer? There are generally 3 camps of people at this point. The first camp, let's call them the slackers, are the people who simply didn't bother to do the problem at all. The second camp, the sluggers, worked out each step, perhaps getting values like 0.5, 0.25, 0.125, 0.0625, and finally 0.02086 with a 6 repeating. The third camp, the skippers, solved it very easily by simply saying 1 over 48. One of the reasons the slackers and sluggers either struggled or even chose not to do the problem entirely is because of how nasty these decimals are, how many computational steps are required to get to the answer. This is why it isn't ideal to work with decimals. Notice that it is very easy to verify that the fraction we got is correct, but it is not easy to see that the final decimal I wrote here is actually wrong. Well then, why don't we just use calculators for all of this? That's what we will find out in this video. Indeed, decimals are a useful way to represent number values, but sometimes can be a major obstacle to developing number sense and math competency if we don't understand where we should be avoiding them. In many cases, especially if you're doing mental or paper-pencil calculations, you definitely want to be working with improper fractions by default. Let's examine why. To start, let's compare how we do basic arithmetic with improper fractions versus decimals. Notice that addition and subtraction are pretty easy with decimals, even if you need to work with infinite decimals. With improper fractions, you'll need to find a common denominator, so this is usually a bit more annoying. So in the battle of addition and subtraction, decimals win. However, let's not rush to the conclusion yet, because there's actually some sneaky nuance we will address later. Now let's take a look at multiplication and division. Suppose you had to multiply or divide these improper fractions. We can not only easily do this, we can even simplify our result by canceling factors first. This should not be surprising because the improper fraction itself is already describing a division, so it is quite easy to group together more similar operations. Now let's take a look at these infinite decimals. How would you multiply these? It turns out this isn't the most impossible task in the world, but the difficulty difference is much larger compared to addition and subtraction. And then there's long division too. In many cases, we want to take the lesser of two evils. Here is an even more convincing argument. Fractions simply allow you to specify values more expressively, and therefore are generally more intuitive. I can take any decimal value and convert it to a fraction pretty easily. However, to convert a fraction into a decimal is more painful. Consider 1 over 7. Notice that the repeating sequence of digits is 6 digits long. We say that the period of this repeating decimal is 6. Even fractions with very small denominators can have very large periods. 1 over 17 has a period of 16. 1 over 97 has a period of 96. Well, we probably don't need that many decimal places, do we? This sounds like a good counter-argument, because in almost all practical applications, you will never need more than 10, so why do we care if the period is big? For starters, imagine I took the value 0.368421 and multiplied it by 19. This would be painful, but if you knew that decimal was the rounded off value for 7 over 19, the answer is immediately clear, instantly. Additionally, it tells you where this value came from, like the ingredients in its recipe. It's not just this random value that emerged out of primordial chaos. It is the result of dividing 7 by 19. This is especially useful for intuition in a pragmatic way. If I say the odds of you winning a particular lucky draw is 0.0013, this is extremely difficult to intuit. But if I had said the odds were 1 in 750, you immediately get a better feel for it. Remember when we said that addition and subtraction was easier with decimals? Now that we understand this point, this is actually no longer an advantage for decimals, at least not a strict one. Consider the sum of these two fractions. We could instead write them as repeating decimals and add accordingly. However, notice that 112 over 239 has a period of 7, and 25 over 53 has a period of 13. That means their sum has a period of 91, the least common multiple of 7 and 13. You may not need all of those decimal places, but now you will have a lot of difficulty converting it back to a fraction, even though this value must be rational. If your next step is to divide the result by 43, this now becomes extremely painful. But it is a lot less bad if you had worked with improper fractions to begin with. By comparison, finding a common denominator or factoring a number doesn't seem so bad anymore. For all of these reasons, improper fractions are desired over decimals. Then why don't we just use mixed numbers? Mixed numbers behave mostly like improper fractions, but fall short when we compare multiplication and division. Consider multiplying these two mixed numbers. The correct way to do this is to treat the mixed number as a sum of its whole part and fractional part, and now we are required to distribute. Then, even after adding all of these parts, we still need to calculate the whole and fractional parts. Wouldn't it be nicer to just leave the improper fractions as they are? Even worse, how would you do division without converting them to improper fractions first? So the lesson here is that anytime you're doing math, by default, you should prefer improper fractions over decimals. However, this does not mean you should always do this or that decimals are never better. It's time to examine the fine print. Like we mentioned earlier, decimals have a slight advantage when it comes to addition and subtraction. But there are other advantages that decimals have. One of them is rounding to the nearest whole number. Notice how easy it is with decimals and mixed numbers, but how difficult it is with improper fractions. In addition, fractions tend to be more useful when we are either working with exact forms or rational values. However, when we want approximations of very messy irrational values, especially when we want to represent them in a computer, it is often easier to just use a decimal representation, not only because the things we want to do with them may be easier, but simply because that's the standard we have and use already. And so the more important takeaway of all of this is that an inflexibility to use fractions over decimals is detrimental to developing mathematical number sense and can make certain problems significantly harder. Otherwise, we should pick the system that fits our use cases. Mastery of math requires that you learn to use the right tools for the right situation. But even if you don't plan to be a stellar mathematician, small tips and tricks like this can go a long way to reshaping your habits and the way you think about these ideas, which can improve your number sense and intuition, critical building blocks for developing further math skills. If you enjoy what you saw, please consider liking and sharing this video and subscribing. See you all next time.